interviews like Google, Uber, or Microsoft, I'll try to take two questions which were asked in like Google as well as in Uber today, and I will try to solve those questions. Both of these questions are based on dynamic programming, and I would like you guys to participate in the in the discussions, and then we'll try to come on to the optimized solution for the questions. And if you have any doubts, then feel free to speak. We'll start with the brute force algorithm. So yeah, if you have approach, then just unmute yourself and then go ahead with the algorithm you have in your mind. Good. So let's start with the questions. So okay, so consider this as a question. So let's say there is a dictionary given to you. Okay, in this dictionary you have like bunch of words. Let's say ABC, SUN, and etc. Now let's take a word. So there is a word given to you. You need to tell whether you can break this word into small words and all those small words are presented in this dictionary. If that is the case, then you need to return true, also, or else you need to return false. So I'll repeat the question again. So you need to distribute or divide this word into multiple small words. And if each of those small words are present in this dictionary, then you need to return true or else you need to return false. So basically you need to find whether this word can be divided into small words such that all those small words are present in your dictionary. So for this, if I try to divide it, then I'll have ABC that is present, but I don't have any A and N, I don't have any SU, F, T. So I won't be able to divide this. So I'll return false because I can divide this, but I can't divide this word. Let's take another example. Let's say we have A, N as well in your dictionary. So this is the word given to you. So now if I try to divide, I can divide it in can and fat, but AB is not present. So, but there is another way. So if I do ABC, AN and FAT, so this is possible, right? Because all these small words are present in this dictionary. So in this case, I'll return true. So if you have any question, and if you have any confusion in the question, then please ask. If the question is clear, then we can start discussion. I hope the question is clear to everyone, right? So if anyone who has joined recently and the question is not clear, then feel free to ask.
Yeah, hi, actually I have joined just now. Can you please just explain once?
Yeah, sure. So the question is very simple. There is a list of words given to you in a dictionary. So let's say this is your dictionary, okay? And then there is a word given to you. Some word is given to you, and you need to tell whether it is possible to divide this word into multiple small words such that all these words are part of this dictionary. If that is the case, then you need to return true or else you need to return false. So even if a single combination exists for which you can divide this word into sub small words and those small words are present in the dictionary, then you need to return true. So for an example, here we have ABC, A-N-S-U-F-A-T. I can divide this and this, but there is no word with which I can create this. But here, if you'll see,
Okay.
I can divide this into ABC, A-N, and F-A-T. So this will return true in that case. And this.
Okay.
So I hope the question is clear to everyone, right?
Yeah, Prakhar, question is much more clear to us. So
Yeah, you can
can I
think.
tell the approach?
No. So yeah, I mean, I'll come on to approach. I'll give like 2-3 minutes for you to think about the solution for this approach. And if you have any approach in mind, you can speak up, and then we can discuss about the optimal solution for this. So I'll give like 2 minutes for you to think. Looks like new people have joined recently. More people have joined recently. So I'll repeat the question for you people. So the question is very straightforward. There is a dictionary given to you. Dictionary contains list of words. So these are the words present in the dictionary. And then there is a word given to you. You need to return true if you can divide this word into small words in such a way that all those small words are present in this dictionary. For example, we have ABC, AN, SUFT. So if you create subwords, then you have ABC, you have AN, you have FAT, but you don't have SU. So you need to return false in this case. But if you take this case, you can have ABC, AN, and FAT. So this word can be divided into 3 words, and all of these are present in the dictionary. So you need to return true. But if you would have divided it in such a way that AB, CAN, FAT, then it won't form a word. Like all those subwords are not present in this dictionary. But there is a combination which is present, so you need to return true. Even if there is even if there is one combination present for which all the subwords are present in the dictionary, then you need to return true. I hope the question is clear to everyone. So I'll give 2 minutes for people who have joined recently to think about the solution, and then we'll try to discuss the brute force solution, and then after that we'll try to discuss the optimal solution. I hope there is no confusion in the question at least. Do you guys have any approach in your mind?
Like I have one approach.
Mhm.
So what we will do, the dictionary words we will keep into a data structure like set, so that we can use this for searching whether it contains or not, and then we will iterate with this ABC. Suppose this string is there, word ABCN, so we'll take a pointer and iterate with each of these characters, saying that let's say A, then we will search on the dictionary, then in the set whether it contains or not. If it like like ABC,
Mhm.
like then yeah, ABC, yeah, and that will not work.
Yeah, no worries. Yeah, but that was a good suggestion that you need to keep all your words um, in your set so that you can easily access all the words. I'll,
Yeah.
more people are joining continuously. Yeah,
Yeah.
I'll just quickly repeat the questions for new people. So there is a dictionary given. These are the words in the dictionary. There is a word given. You need to divide this word in such a way that in you need to divide this word in small word, and if all those small words are present in the dictionary, then you need to return true. So here in this case, ABC, AN, and FAT, all 3 of them are present in this dictionary. That's why we are returning true. But if we try to divide this word in small words, we won't be able to divide. That's why we'll return false in this case. And yeah, someone just suggested a solution, but like the first part was correct and the second part was incorrect. So the proposed solution was that we can keep all these words present in the dictionary in a set so that we can easily search. I mean, our searching is much more optimal compared to actually going through an array and then searching for these words. But we still need to figure out like how we will divide the words so that we can check if there is a combination exists for which all those words are present in the dictionary. Anyone else? Any approach in mind? We can start with the brute force algorithm as well if you have something in mind. Then
So what we can do, like we have a word in the dictionary. So these words are like 3 length, 4 length, and 2 length. So we can create substrings out of this particular string. Okay, of those like 4, 3, 2, and like 5 words substring out of these this particular string, and then we can compare whether the words exist from that or not.
okay, just a second, just give me a minute. Hello. Yeah. So yeah, your approach won't work. So consider this, right? So even if you create small words, let's say you created of length 3, but you still need to check whether this substring exists or not. How you will check that?
Abhishek, I think we can use a try data structure,
Okay.
and we'll keep track of the for all the words in the given dictionary. We will
So you're planning
maintain.
all the words present in the dictionary in a try, or can you please add more details to your solution?
We are given the words, or we are given this only the words to find, or one word to
So
that
you
take.
have this dictionary. Okay, these all words are present. And then there is a word given to you. You need to return true if you can divide all this word into small words such that all those small words are present in this dictionary. The question is clear now, right?
Yeah.
Okay.
No, that won't work. How it right? Try, no?
Okay. So it looks like there were multiple approaches which were mentioned, but I'll try to give you a small hint. Maybe if you can think in a correct direction. So what you can do is you need to check all the possible permutations and combinations. So let's start. Let's say we have a pointer. So let's say if I check this, if this is present in my dictionary or not, and then what I do is I put this as another substring. It's a recursion. I'll say that if it is present in the dictionary, then check for the remaining substring if that is present in the dictionary or not. Now, if it is not present, then I'll keep on creating this substring till I don't find a word in the dictionary. Here I find a word in the dictionary. Then what I'll say is check if there exists a substring in the dictionary or not. Now, this is like a new word for me. Again, I'll start doing the same thing. I'll check if this exists in the dictionary or not. If it doesn't exist, Then I'll keep increasing my pointer. Now I'll check if this exists in my dictionary or this exists. So what I'll try to do is, again, I'll try to find this as a part of the, this is in the another dictionary. Now again, this doesn't exist, this doesn't exist, this exists. So I'll return true. This is also true. This is also true. So overall my answer will be returned this. So this is a recursive approach. Can anyone tell me like how it is working, and can anyone explain in detail? And then we can discuss.
So here what we are doing, if the matching substring is found, we are we are splitting that string, the actual string into parts. Okay, the found one and not found, like the remaining that needs to be checked. Is it correct? And then we are processing whatever is not been checked in the next iteration.
Something like that we are trying to do here. So I'll try to explain you people with the help of an example or with the help of a tree. Okay. So let's take an example. Let's say we have A, B, C, A, M, A, B, C, A, M, T. Okay. And my dictionary has A, B, C, and it has C, A, N, and it has A, B, and it has A, N, T. Okay. Now let's try to break this into substring. So what I'll do is, first I'll divide this in this. So let's say I'll divide this. I'll check if A exists or not, and then B, C, A, N, T will be my some other string. So A doesn't exist in this dictionary. I'll return back. Now what I'll do is I'll say that if AB exists or not. So is A, like our AB exist in this tree? Yes, AB exists. So what I'll do is now I'll try to find if C, A, N, T. So if AB exists, and if there is a subword, there, if this substring is also present after breaking down in this dictionary, then it is true, correct? So now I'll try to find C, A, N, T. Now what I do is I divide it into C. First I check for C. C doesn't exist. Then I check for C, A, N. C, A, it doesn't exist. Then I check for C, A, N. C, N exists? Yes, C, A, N exists. So what I'll do is I'll try to search for T, but T doesn't exist. So this will return false. This will also return false. This will also return false because we have checked all the combinations. This will also return false. Now what I'll do is I'll add C also in this dictionary. So now what will become? It will become ABC. Now if ABC, we'll check if ABC exists in my dictionary or not. So ABC exists here. So what we'll do is we'll try to find if ANT exists in my string or not. Now what I do is I divide again ANT into A. A doesn't exist. AN, let's say we have AN as well. So does AN exist? Yes, AN exists. So I'll go and check for T now. Now, if T exists, T doesn't exist. So I'll return false. I'll return false here. Now I'll try to check for ANT as well. If ANT exists, yes, ANT exists in my string. So I'll return true from here. I'll return true from here. I'll return true from here. And finally, I'll return true because this substring can be divided into two parts with the help of ABC and ANT. So is the approach clear to everyone? This is the brute force algorithm which we are trying to, which we have implemented right now. If you have any questions or confusion, then please ask. Is it clear to everyone? If it is clear to everyone, then we'll try to write the code for this one.
I did not understand this part of three. The first part I understood why it was it is actually true, but it is returning false. But the second part has to connect.
Abhishek, can you just draw the stack frame how the recursive calls will happen here for a smaller example like.
Sure. Let's try to take again this. Okay, I'll take the same example. And then again, I have A, B, C, A, and D. Let's say A, B, C, A, N, and A, N. Okay, so first I'll start my pointer from here. Okay, now what I'll do is I'll check if AB exists, if A exists in my dictionary or not. That is a simple find check. So this is my dictionary. I will check if A exists in my dictionary or not. A as a word. So can you tell me A exists as a word or not here? It doesn't exist. So what I do is I will add B as well in this substring. So now this will become AB. Correct? Clear so far?
Yeah.
So AB exists in the dictionary or not?
Yes.
AB
Yes, it does.
Now what I need to, if AB exists in my dictionary, then I need to search if CANT. So if this exists and this also exists, then it means that all the, like we can form the string, like the substrings from this string, and all of those substrings exist in the dictionary, correct? Is this much clear? So if this exists, and if I can divide this substring into multiple substrings so that this substring also present in this dictionary, then can I say that this is the word, this word can be divided as a whole into substring which are present in the dictionary, correct? Are you guys following or not?
Yes,
Yeah.
yes, yes.
Okay, that much is clear, right? Now what I do is AB is clear. So I know AB is a substring. Now what I need to do is I need to put CA. So earlier what happened was in my this stack ABCANT as a whole came to check whether it exists or not. Now what I'll do is I'll try to check for CANT. Okay. So now CANT. Now what I'll do is again I'll do the same thing. Can I from C as a substring? C as a substring doesn't exist in the dictionary. CA doesn't exist, but CAN exists. So if this exists, then if I can make this as a substring, so I'll check for T. So if T exists, then this whole word will be my. So this whole word can be divided into the substrings. But if I come to T, T doesn't exist, and there is no more letter remaining. So I'll return false from here.
Yes.
From CANT as well, I'll have to return false.
No, it's true.
No, why CANT is true? You can't. CAN was no CANT as a whole. You were not able to find, right?
Yeah, correct, correct. So it will be false.
So now you checked for CAN. Now you have to check for CANT as well. CANT doesn't exist in your this dictionary.
Yes,
So I will return false from here as well.
yes.
Now what happens? Again ABC. Now AB was going on. So can I say now we can check for ABC? Because
Okay.
AB and CANT returned false. So now what I'm checking for is ABC.
Okay.
ABC exists in my substring in the
Yes.
dictionary. So
Yes.
what I'll try to check now is ANT.
Okay.
Now
Yes.
ANT will go into this.
Yes.
Okay, just a minute. I don't know why. Okay. Now ANT will go into this.
Yes.
Now I'll check for ANT. So if A exists, A doesn't exist. AN exists, yes, AN exists. So what I'll try to check for now is whether T exists or not.
Hmm.
So T doesn't exist here. So again, this will return false. Now I'll try to check for ANT
Okay.
as a whole. ANT exists.
Yes.
So here will return true. And ABC was already true. ANT is also true. So now ABC ANT is a string which can be divided into substrings. So we will return true from here. Is it clear now?
Clear.
Yes.
Okay. If that is clear, then let's try to write the code, brute force code for this particular question now. Okay. Anyone has any confusion so far, then please ask. I hope there is no confusion. So let's proceed to the solution for this question. So I'll try to write the solution in. Okay, do one thing. I'll give you guys like 2 minutes to think about how to write the solution for this question. And then I will try to write the solution. Just try to write the recursive, recursive. I'm not asking you to write the complete code. If you can just write the recursive approach or the method where we are actually doing the recursion, then you'll be able to understand it in a better way. So I'll give you like 2 minutes to think about a solution by your own now, and then we can discuss and I'll explain you the code as well. So I'll give another like 3 minutes for you guys to write code by yourself, and then we'll write the final solution. Anyone, any confusion? Okay. Did anyone try to write the code for this one? Yes. Okay, cool. No worries. I'll try to write the code. Okay. So let's say we have int main, and here we got the string. So let's say we got a set of strings and we call it as dictionary. And let's assume that we have multiple set of words. Okay, ABC, AN, ANT. What else we have? Let's say we have CAN, etc. Let's say we have AB as well. Okay, so let's declare this outside. Okay, and then we got a word, string word. So we'll take input for word, and then what we'll do is we'll call word break. There's a method, and we'll pass the word in this, correct, and the starting and the size of word plus 1. So that is the last, or size of word will be your, sorry, size of word minus 1. So these are representing the starting index of the word and the end index of the word. Now let's try to write the word break problem, the word break recursion itself. So you need to return true or false. So let's say I'm returning Boolean or bool, word break, string word. What else we have? End, start, end, end. Okay. Now what we do is that, just a minute, just give me a second. So it means that we try to see if the word, this subword exists in the dictionary or not. So if okay, st is ever greater than end, correct, then for now let's say we are returning true. Now what I'll try to do is for int I is equal to st, I is less than equal to end I plus plus. What I'll try to do is I will say that string substring equal to word dot sub str. This is simple, or whatever, word dot what I word dot substring. I forgot the exact function name. I think it's sub str only. What we do is we find, so we have the word from the starting index we need to take, and what will be the length of my end index? The length of my end index will be, so this is representing your index, right? So I'll say that I need to pass the length. Let's take the string function, just C++ string. Okay, it is substr only. So it takes your string, whatever, from which index you want. So we want from starting index and of what length you want. So this represents your length. Okay, this represents your length. This represents your index. Okay, and this represents your word. So in this word, from this index of this length. So length will be what? I minus st plus 1. So consider this case. Let's say we have our word is, let's say, A, B, C, A, and T. So first I'll check for A. So I'll start from 0 index. I'll go till T. So that is equal to size of word minus 1. That is equal to 5. 0, 1, 2, 3, 4, 5. Correct. And what I'll do is I'll try to find the substring. So first substring will be what? Starting from 0 index of length what? 0 minus 0 plus 1 of length 1. So that will be your A. Correct. So I got the substring. Then what I do is I check if substring dot find, sorry, if dictionary dot find, I need to search for substring, double equal to, if is not equal to, dictionary dot end. Correct. That means if it is not equal to end, that means we have found the substring. So then what we'll try to check is we need to find the word break if this substring exists, and if the remaining substring also exists, then it will be true. So what we'll do is we'll try to see. So here we'll initialize our, we'll take a boolean equal to false initially. Bool of is word break. Okay. So if is word break, I'll do what is word break equal to, what I'll check now is that this substring exists. So now I'll check if word break is word break, and what I'll pass here is substring. The remaining, I need to call the recursive function. So is word break equal to word, I'll call word break from here with what? I'll call word break from here with word, comma, my end will remain end only, st plus 1, comma, end. Correct. If I can find this word break, then this word break will become true. So what I'll do is word break or word break of this. Now I'll keep on doing this till the end, and then from here what I'll return is word break. Okay. So if I can break this word, then I'll return true. Otherwise, I'll return. Is it clear to everyone? So this is a very recursive, okay, let's go through the code once again. I'll try to explain it again. Let's say we have got A, B, C, A, and T. So word will be your A, B, C, A, and T. String will be 0, end will be 5. ST is greater than end. Yes, my 0 is greater than, no, my 0 is not greater than 5. So what I'll do is I'll initialize my is word break to false. Then I will start a for loop from 0 till 5. So my substring first will be formed is with 0, 0. Correct. So that will be just A. So my A doesn't exist in the dictionary. So again, this for loop will increase. I will increment. It will become what? 0, 1. So substring will be AB. If AB exists, yes, AB exists as a substring. Then what I do is I say if AB exists, then check for the word not from ST plus 1. It will be I plus 1. So word I plus 1. So if CANT exists or not. Here I am checking if CANT exists as a subword or not. Again, this ST will become what? 2 and will still remain 5. My word will be same ABCANT. So word is ABCANT. Now my ST is equal to 3 and ST is equal to 2 and end is equal to 5. Now what I do again is I initialize another. So this is a recursion function. So this will be another variable initialized to false. Now what I'll check is, again, I will try to divide CANT into substrings. So first I'll check for C. So C exists, no. Then again CA exists, no. CA. So okay, let me tell. So let me explain this. So let's say ST is equal to 2. So I will be 2, I is less than equal to 5, I plus plus. So substring will become what? ST of length what? 2 minus 2 plus 1. So of length 1. So only C will come here. Now C doesn't exist in the dictionary. Then again my I will increment. So I will become what now? I will become 3. So ST, so substring will become starting from length, from index 2 of length 3 minus 2 plus 1, which is equal to 2 of length 2. So this will become C and A. If we'll check if CA exists, CA also doesn't exist. Then what we'll do? Again, I will be increment and it will become 3. Now we'll check for CAN. CAN exists? Yes, CAN does exist. So what I'll do is, now if our CAN exists, I'll check if the remaining word can be broken down or not. So I'll do I plus 1. So what was my I? I became here 2, 3, 4. So now I plus 1 will be 5. End is also 5. I go here. What I check is, if I is equal to ST, I is less than end. So 5, end is also 5. So the length will be equal to 1, because 5 minus 5 plus 1 will be 1. So I'll check if 5 exists in the dictionary or not. 5 doesn't exist. So I will again increment the count. This will become 6. So now I is not less than end anymore. So I'll return is wordBake, which was false only. Now this will come back to CANT, but I was not able to divide CANT into substring. So again, I'll increment my I. So I will become what? 4 now. So the substring which I'll try to search is CANT. So sorry, I will become 5. So I'll try to search for CANT. Now CANT itself doesn't exist in the dictionary. So this will also return false because I was not able to find the word. So now I come back to AB and I was not able to create with CANT. So this will be gone. Again, my I will increment. Now this will become what? I was equal to ST was equal to 0. I will be equal to 2 now. So the length will become 3. So I'll check if ABC exists or not. Now ABC exists. So I'll try to check if the remaining ANT exists in the string or not. So now ANT will go here. Starting index will be 3. End index will be 5. Now we will check for A. Here A doesn't exist. Then we'll check for AN. Now AN exists in my substring. Correct. So I will check for remaining T now. So ST will become 5 and will become 5. Now again T doesn't exist as substring, so false will be returned. Now I'll try to check for ANT because automatically this will increment. So my I will become 5 and ST was 3. So from 3 to 5 I'll check of length 3. So now ANT, if ANT exists as a part of dictionary or not. ANT exists. Now what I'll do is I'll try to check for the remaining word. So my I plus 1 will become what? I was 5, so I plus 1 will become 6 and will remain 5. I'll call this function. Now your ST is greater than end. So this will automatically return true. So word break was false. False or true will become true because I was able to find ANT. So this will return true. Now because this returned true, I was checking for ABC or ABC and ANT. So this return true, ABC already exists. So overall, this word break will return true. What we can do is, here we can add another condition so that we don't need to check for all the conditions. If word break is true, if is word break itself became true here, if word break, then return true. So that you don't need to check for ABC, because your word break become true, you don't need to check for ABCA as a substring now, and then NT as a substring. So this will return and this function will work. Is it clear to everyone?
Yes.
Was it, I mean, see, the thing is that it's a recursive problem and it is very interesting problem. And you will see there will be lots of problems like this, and asked in the interviews. And it is not very difficult. You just need to understand the recursion. That's it. So if anyone doesn't have any question, then we will try to do a dynamic programming on the top of this. We'll try to apply dynamic programming. And I'll explain how we'll do that as well. So if anyone doesn't have any question, then I'll proceed from here. I'll share this code with you. Yes. Any question?
Yeah, what will be the complexity of this recursive solution like?
Right now, the complexity is like we are trying to check all the possible combinations and permutations and permutations are not permutations. Oh, yes, actually, we are trying to check all the possible combinations.
Yeah.
Correct? So either what we are doing is, let's say A, B, C, A, and T. So what we are doing is either we are taking this or not taking this. Then we are taking this or not taking this. So every time we have two choices. Correct? Either taking or not taking.
But I was thinking like if we are given a length n, then we have to find all the substring of length 1 plus 2 plus 3 plus 4 like.
Correct. So not just that, you also need to check whether those substrings exist or not. Just finding won't help. You need to search for that, and you need to form the substring of this as well. This as well. Now there can be a combination where A, B, C, A, N, T can also exist. A, B, C, A, N, T can also exist. So you need to check all those combinations as well. So basically, the easiest way to find the complexity in such cases is just, so here you're taking a word or not taking it, right? So always you're taking a decision, correct? So if you create a tree, how it will look like is either you take A or check for B and take C, A, and T, or take A, B, C and take A and T. Like this, you will keep on forming. So always you have a choice between a word. So either you take this word or you don't take this word. So the complexity becomes your 2 to the power n, which is exponential. There are n possibilities, right? And there can be 2 to the power n different possibilities.
Yeah.
Because you either take one or you don't take one. And you need to check for all the possible combinations in that case.
Correct. Yeah.
So usually the complexity is exponential in such case. Okay. Now let's try to optimize this complexity. So do you have any solution in mind to actually optimize this complexity itself? So if you would have observed one thing, right? Here we might be unnecessarily checking for the substring which we have already traversed. So let's say in case of CANT itself. Okay. So let's say C also exists in our dictionary. Or let's say, okay, no, C doesn't exist. Let's say we would have checked at that time when we were checking for A, B, C, A, and T. Correct? We would have checked for, let's say CA exists in our dictionary. Okay. And NT doesn't exist. So we would have checked for NT already. Do you think that we need to check for this NT again? Because we can come onto NT again from a different path, right? Like from ABC, A and NT, or from ABC, or from AB, CA and NT. We can come from multiple different paths. So if we would have, or we can come from ABC and A and NT. So if we would have already checked with this is not a substring, do you think that we need to check again whether this exists as a substring or not, the remaining part?
Correct.
Okay, let me explain you by example. Maybe that will be helpful. So let's say you have this A, B, C, A, N, T, and in the subst you have the A, B, and you have A, B, C, okay, and you have C. Okay? So they only these words exist in your dictionary. Now let's say you start with A. A doesn't exist. AB exists. So you will try to check for C, A, and T.
Correct.
Correct. So I check for C, A, and T. Now C exists. So I'll try to check for A and T. Correct. Because C exists in my dictionary. Now A and T, there is no way possible to actually form from A, N, and A and T to form a word. So I know that A and T as a substring will never exist in my dictionary. So you will recurse back, you will return false, you will come again here. Now what you do is you check for ABC. Now ABC exists, so now you will try to check for A and T. Do you think that you know that you have already traversed A and T and this was false? Do you think that you should go and traverse A and T again and check whether this substring exists or not? Because you will have to again check all the possible combinations of A, AN, ANT, and there might be many more words here, right? So if let's say A also exists, then you will go and check for A and AN and then ANT. So you will unnecessarily keep on checking for the words for which you have already traversed, correct? Do you understand what I'm trying to check? Say. Confusion. Please ask if it is not clear. And if it is clear, then I'll tell you how to modify your solution into a deeply. Okay. Looks like no one has any confusion, so I'll proceed. So what I'm trying to say is you are unnecessarily keep on checking this, which will increase your complexity. So what you can do here is I maintain an array, let's say DP outside of size of my size. I know the maximum size is 1000. Okay. And what I do is if I know that this word break is equal to false, then at that particular index st, so always I'm starting from st. So what I'll do is I'll mark before returning is word break. What I'll check is if is word break return true, and before that I'll do dp of st equal to +1 if is word break. Else here I'm returning false for sure because I would have returned true from here itself, right? If I would have got this, I would have returned true from here itself. So I return what here? dp of st equal to -1. That means it doesn't exist and return is word break. And what I'll check is if every time I'll proceed only when if dp of st double equal to 1, then I'll directly return true if dp of st is equal to -1, then I'll simply return false always because I know that I've already traversed and this is always false. Yes. And if dp of st, so initially everything will be 0 because that's how it works. Like if you create a global variable, it will be initialized to 0. So if it is 0, then I'll check and I'll update the dp of st. So this will give, so the complexity will be reduced to what now? Order of n square from 2 to the power n. Okay. So now let's move on to the next question.
Abhishek, like in the DP array, why can't we modify it? Let's say we want to search for the word and in the, so we can just pass the index of A and index of T to it and store, let's say -1 when we don't encounter.
Sorry, can you come again?
Like I am telling about when we maintain the DP array,
Mm-hmm.
let's say we want to search for the word and in the DP array.
Okay.
So when we encounter, when we don't like when we first time when we don't encounter, we can set the starting index and end index of the string to -1. The index of A and T to -1. So when we search for the next time for the word end and check the, if the starting and the end index is -1, we don't need, we can confirm that there is no word end in that.
No, but why do you need to maintain that? See, always you are proceeding in one direction. It's not bi-directional, right? So if you go from A N, so what I'm saying is from starting from A. So here what it represents is starting from that particular index ST. Let's say your ST is equal to 3 and your word is A, B, C, A, B, C, A, and T. What I'm trying to do is if you start from index 3, from index 3, you can't create a word with A, comma, NT. You can't create a word from A, comma, AN, comma, T. You can't create a word with A and T. So because you're always, so you can't divide any word after this index into the substring, which are present in the dictionary. So you don't need to maintain that separately. I am saying that this from here itself, there is no substring exist at all.
Yeah, like I
Why do
think
you want to maintain T again? Automatically, it will happen at T because let's say AN exists. Right? Let's say AN exists.
okay,
Then you will go and check for T. Correct?
correct.
But T itself won't exist. So before coming back to A and T, you will at T you will mark what -1 automatically because it doesn't exist for you.
Yeah,
You don't need to maintain that separately. You getting my point?
yeah, got it.
It will your recursion will automatically take care of that.
Okay, okay, thanks.
Cool. Let's move on to the next question. Okay. So let's say there is a, so I hope this is clear to everyone. Cool. So the next question is this. Let's say you have got an array of string, or let's say array, not array of string, just you just got an string, got array of characters I meant. So you got a string, let's say GEEK. Okay. Geeky friend. Okay. Or let's say, yeah. Okay, this is one string. I'll take another one. Let's say ME or me. Okay. So this is the these are two substrings given to you. Now the string is given. Okay, so let's say you need to return the maximum palindromic substring length which you can form in this string. So in case of geeky friend, only E is a palindrome. So here you will return 2. But in this case, if you take this as an example, TT, EM, and MEM. This is a palindrome. Correct? Everyone knows, right, what is palindrome? So basically palindrome is if you try to write it in the opposite direction, like if you if you check all the words. So basically if you reverse the complete string, then the string remains same. So if I reverse that this complete string, then my string remains same. Okay, so this is my palindrome. So the length of palindrome here is 6. So my answer for this substring will be 6. Let's take another example where you have METCTEMMA. So what will be your answer in this case? So this is my substring of length 7. So if you try to write it in the reverse direction, then also you will get the same string. So the answer is 7 here. So you need to return the maximum of symbol in a given string. Substring of palindromic substring of maximum length, and you need to return that length. So hope the question is clear to everyone. If you have any confusion in the question, then please ask. Question is clear, right?
Yes.
So now we'll solve the problem. Can you people hear me?
Yes.
Yeah, yes.
It looks like there is problem with someone else. I got a message saying that the audio is disconnected. Okay, any approach in your mind? Any approach? I mean, I know this is a trickier question. It is not very straightforward. And like, you might have faced this question sometime somewhere in the interviews or similar questions on palindromes or matching the substrings between two strings.
I have an approach here.
Yeah, tell me.
We'll pass the entire string and the starting and the end index of the string to the function,
Okay.
and we'll compare the first and the last string.
Okay.
So we have two choices to make then, if it is a match or a mismatch. If it's a match, then we'll increase our count by 1.
Okay.
And if it is not a match, then we have to make two choices. Like we have to include the entire string till n-1, or we'll exclude the first one and take it to n, and then again we have to recur it back. That two string will be treated as a string, and we'll pass that to the function again.
And if it's a match, then what you will do?
No, we'll keep track of it. Whenever we are finding a match, we will one variable will be there. That variable will whenever a match will be found, we'll increment that variable, and we will take the maximum of the two, that 1 to n-1 and 2 to n, the two substring that we are comparing. If there is a mismatch found, so we'll take the max of that two.
Okay, got it. And if it's a match, then you will increment your first pointer and decrement your second pointer, correct?
Yeah. If it's a match, then we'll increment the first.
Answer, like, okay, let's take an example. Let's say if this is the string given to you. What is the length of substring, palindromic substring here, as per you?
It will be 0.
Yeah, but your answer will be? So you are matching this, right?
Yeah,
And then you are trying to test this.
correct. No, first we will match. Yeah, we will. Yeah, correct. I got it.
You can't start from the end because it could be possible that, let's say, this is my example. Let's take another example. So you found a match here, correct?
Yeah,
But if you would have ignored this and you would have taken this, then you would have got 4 as a length.
correct.
After you have taken this, you won't get anything because you will compare this now and you'll compare this now with, so nothing will match. So you'll return 0, but that's not true. The answer is 4 here. You getting my point? So
Yeah.
you're starting from the end. You
Okay.
need to think in a different direction.
Yeah.
Yeah, but it was a good attempt. If you'll see, right, this both of these questions I've taken from some interview. I think it was asked in Uber sometime. Yeah, so word break we have already done, and now, okay, not here. I took it from somewhere. So yeah, longest palindromic substring we have taken from Google interview, and this question, this question, this question, and this question were discussed in the last class. These 4 questions, and this we have discussed in 3 class before, I think. This I've taken in this class, and I've taken one from the Uber interview. We'll try to cover more questions on DP because I feel that like most of the people face difficulty in these questions only. I think this question was asked in Facebook as well. Yeah, word break and this, both of them were asked in Facebook as well. You see the same question which we have solved right now, and this is the longest palindromic substring which we are trying to solve. Okay. Anyways, yeah. Does anyone has any approach in their mind? Anyone else? If you want to give try.
Can we try from zero index and minus our loop from size -1 and then like size minus I, right? So suppose the string is A, B, C, A, right?
Okay.
So first it will start from A, okay, and it will check the complete string A, B, C, A. Then it will move to next. The first index will be same A, and then it will minus the size A, B, C. Then it will check the ABC. Then it will check the AB and will complete to the A. And then it will check all the substrings that they match with the palindrome or not.
Okay. So you will actually basically, from what I've understood, yeah, this is a good approach. And you, I think you came onto the brute force solution. So what? I don't know what what is your name, but yeah. So let's say what, and from, just let me know if I understood it correctly. So what he's trying to do is, so you can easily, so if there is a string,
Yes.
you can easily check if it is it is a palindrome or not. The way to
Yes.
check it is, you will match this with this, this, this. If it is not matched, then you'll return false.
Yes.
What he's trying to say is, you will try to create all the possible substrings. One possible substring starting from A is A, then AB, then ABC, and then ABCA. And you will keep on storing the length. And then you will start from B. You will check for B, just B, then BC, then BCA.
Yes.
Start from C. We'll check for C. and CA. And then you will start from the last A. Correct. But in all the cases, the length is only, so your answer will be 1 because the only substring matching is either A or B or C or A. But this approach will work fine in this case as well. Let's take this example. So if this is not a substring, so we will check for AA. So this will return true, 2. So we'll store 2 as our maximum so far. Then we'll check for AAB. It is not a substring. Then we'll check for AAA, AABB. It is not also a palindromic substring. Then we'll check for AABBA. It is not. Then we'll come on to this A. We'll try to, so just A will be 1. Then we'll check for AB. It is not. Then we'll check for ABB. It is also not. But when we come to ABBA, then it become 4. So, and it is a palindrome. So we'll put 4 here. Then we'll start from B, and you will keep on doing that. You will basically match all the possible substrings in a given string. And what you will do is, so that complexity to find all the substring in a given string is order of n square.
Yes.
And then order of n to match your whether it's a to find out whether it's a palindrome or not. So overall complexity becomes order of nq, which is correct. So this is a brute force solution. Everyone understood? I can write the code for this one, and then if you have any confusion, then you can ask. Okay. So let's try to write the code for this one. Any confusion? If anyone has any confusion,
No.
okay. So let's say and in my main I got a string str equal to something, let's say okay, and then okay, and then I pass str here, okay, and that's it. Just a second. Okay. Okay. Now I'll see it length equal to this and see out. Now find longest value. STR. So what I'll do is size size Hello, can you guys hear me? Hello. Hello, can you hear me?
Yeah, yeah.
It looks like someone entered the meeting, got disconnected.
But your voice is breaking.
Okay, no
Anyway.
worries. Okay, just a minute. Give me a minute. Let me know if it is better now.
Yeah, now it's fine.
Just a minute. I'll just. Can you hear me now clearly?
Yes,
Yes.
fine.
Okay. Okay. I think I won't write the main function. I'll directly come onto the function which I was writing because you're running short on time. So I'll try to quickly write it. So let's say we have to return int with length palin, and I'll take int string str, and then what I'll do is just tell me something if I make a small mistake because I'm writing it faster. I is less than str dot size, and do I plus plus. What I'll do is for int j equal to I, j is less than size str dot size j plus plus. Then what I do is I'll find the substring. So substring equal to str dot substring. I need to pass the index and the length. So index will be my I, length will be my j minus I plus 1. Then I check palin. What if I'll pass check palin. I'll pass my substring here. If that is the case, then I need to return maximum length possible. So I'll initiate int max length equal to, let's say, 0. If this is the case, then what I do is I'll increase my max length to j minus I plus 1, and I'll keep on doing this, and then I'll return max length. And I hope you will be able to write the check palindrome function easily by yourself, or I can write it quickly. Bool check palin. We haven't come on to the optimized solution yet. Strings str, and what I'm doing is here I'll check int I is equal to 0, j is equal to str dot size minus 1, and while I is less than equal to j, basically while I is less than j, not equal to j, what else? Oh, sorry. Or either of them is, actually this is fine. If arr str of I is not equal to str of j, then return false. Otherwise what we'll do is I'll do I plus plus j minus minus. We will keep on doing this and then return true. So this will be again order of n, and these are two for loops. These are of order of n. So the complexity will be order of n. So this solution is clear to everyone. Does anyone has any question? Please ask if you have. So this is clear, right? So should I proceed to an optimal solution now?
Yes.
Okay, cool. Thanks. So let's try to come on to the optimal solution now. So let's take a small example first and then try to understand. Okay. So let's take an small example. Let's say we have G, E, E, K, Y. Okay. And I can write this, I'll again write G, E, E, K, Y here. Now tell me something. If this, as I mentioned earlier, if it is a palindrome, then if you will try to match from both the sides, the string should remain same, right? Basically, if you try to reverse the string, then the string should remain same, right? So what I'll do is consider this is my string, this is my one string and this is my second string. Okay. Now, can I say that if I take only this part of the string and this part of string, they will always match? So can I say that always the length at the same index will be 1? If you agree, then let me know. If you don't, then ask for it. So here, can I say that this G will always match with this G, this E will always match with this E, this E will always match with this E, this K will always match with this K, and this Y will always match with this. Okay. Now let's say if I try to match string of length 2. So what I'll do is I'll try to match this G with this E, all the length of length 2. So this will become 0 because we can't match these two. These won't also match. This E and this E will match. Correct. This E and this E will match.
Yes.
Correct. So can I say that here this is of length 2? Correct. Because if you'll see here, actually this E and this E matches, right? So this is my E at index what? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So at index 1 and 2, this E and E are matching. So I'm putting 2. Now this E and this K can't match. So can I put 0 here again? In this K, this Y doesn't match. So I'll put 0 here again. Correct. Now I'll try to match of length 3. Now, see, now if I want to match of length 3, then what I'll do, I'll try to match this G with this E. Correct?
Yes.
But if these two matches, then it should also mean that, see, the thing is that in case of palindrome, there can be two types of, if it's of even length or if it is of odd length. If it is of even odd length and then there are some string here, then also it can match, or if it is of even length, then also it can match here. So till 2 we need to find like this. But if we are at length 3, then at length 3, then if this and this is matching and this should also match. Similarly at length 5, if the string is of length 5 and this are matching, this should also match length of length 3. So where we have stored the result of length 3. So let's say this is my string, right? So let's say if I'm trying to match this G with this Y, the result of E to K will contain, from this E to this K will contain whether it is matching or not. So what I'll do is I'll always check the previous result at index of what? I plus 1 and J minus 1. So if I plus 1 and J minus 1 are matching, and if ith element here and jth element are also matching, that means that this is completely this substring is a palindrome. Do you agree or not? Let's take an example where we were trying to, let's take a bigger example. Maybe that will make it more clear. So what we had A, M, 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 E, T, T, E, M. A, A N E D T E M. Wait, this will become difficult for me to write. A M E D T E M. And here also A M E D T E. Now this A and A will always match. This M and M will always match. This will always match. This will always match. This will always match. This will always match. And this will always match. Any confusion so far? Now we'll check off length 2. AM and M are not matching. So this will always be 0. This and this M and E is also not matching. So this will be 0. E and T is also not matching. 0. T and T. So this T and this T is matching, right? So we'll index it as well, let's say. Now this at index 3 and index 4 are matching. So can I put 2 here? If that is that clear? Okay. Now what I'll try to do is I'll try to match this T with this E. It won't match, so I'll put 0 here. And with this E to this M, this won't match, I'll put 0. Now see, if I'm trying to match this A with this E, correct? Then this substring should have also matched. So M was matching, right? But A and E itself are not matching, so I'll put 0 here. Now I'm checking off all the strings of length 3. So I'll fill like this. So now this M to this E, they are not matching. So anyways, this will be 0 even if E is matching. So this will become 0. Now this E to this T, correct? This is also not matching. This E to this T is not matching. So I'll put 0 here. Correct? Now this T to this E is also not matching. So I'll put 0 here. Now this T to this E. Now this T to this M is also not matching. So I'll put 0 here. Correct? Now I'm trying to match of length 4. So A and T are not matching. So can I put 0 here directly? Now M and T are also not matching. I'll put 0 here. Now this E and this E are matching. Correct? So index 2 at index 5. So if you'll see at index 2 and index 5, they are matching. Now I need to check whether the substring of this matches or not. So where was it? At index 3 and at index 4. So at index 3 and index 4, I had 2 and that was matching of length 2. So what will happen? 2 plus 2. So this will become what? Because E and E are matching and this was of length 2. So 2 plus 2, this will become what? 4. So I'll put 4 here. Now again, this T with this M is not matching. So I'll put 0 here. Now maximum I've got so far is 4. Now what I'll do is I'll try to match this A with this T. These are not matching. I'll put 0. This M with this E. These are also not matching. I'll put 0. Now I'll try to match this E with this M. This is also not matching. I'll put 0. I'll come to A and E. A and E are not matching. I'll put 0 here. Now M and this M. This M and this M are matching. So see, 1 to 6 are matching. So ideally if 2 to 5 matches, then only I can say it is substring. So I'll check from 2 to 5. Where is my 2? 2 is my here. And where is my 5? 5 is here. 2 to 5, which is at 4. So they are matching of length 4. So this will also match. So this will become what? 6. 4 plus 2, 6. Correct? Now I'll do what? I'll match A to M. A to M are not matching. This will become 0. My answer is 6 and this will be my answer. Okay. Do you guys understand what I'm trying to do here? Please ask if you have any confusion, because this is very important question. And there are like many questions asked in interviews which are similar to this question. And like most of the questions are solved by this strategy itself. You write under the same string or the other substring given here, and then you try to match the values, and you will like most of the palindrome related questions will be solved with this method of strings. So if some questions comes like, then the complexity here will be order of n square. Clearly you can see, and the space will also be order of n square. N is the size of the string. Any questions? I can write the code for this one if you people want. But before that, if you have any question, then please ask. So is it clear to everyone? No one has any question? Please ask if you have any question because I can explain it again.
Sir, can you explain how it has become 4 and 6?
Okay, sure.
Part. Thank you.
Cool, cool. So let's say we are standing at this point, right? We were trying to match this E and this E, correct? This E and this E was at index 2 and at index 5. So my index was this index. Now, if I want this complete E to this E to be a palindrome string, then this also has to be palindrome. Because if this is palindrome, then this part can act as a palindrome, otherwise not. So what I do is I go and check the ith. So this, let's say this is my I, this is my j. So I check I plus 1th part and I check j minus 1th part. So I was 2 and j was 5. So I'll check from 3 to 4 and I would have already stored this result because this will be of a smaller length because we were doing of length 1, then length 2, length 3, length 4, right? So from 3 to 4. So if I check index 3 and index 4, what was there at index 3 and index 4? We found 2. If this was 0, then definitely this will also be 0 because this is not a palindrome. But here we found 2 of length 2. So what it will become? 2 plus these 2 are also matching. So the length will become what? 2 plus 2, 4. So I'll put 4 here. Similarly, when I was matching this M with this M, these both were matching. So what I'll do is I'll check if my 2 to 5 matches or not. So I go to index 2 and index 5. So this, if this would have been 0, then I couldn't have matched. So, but these are not 0. So what I'll do is I will, or let's take another, let's say we have A as well here. Maybe that will make it more, no, this won't make it more clear. Let's say we have, okay, let's say we have B here and we have A here. Correct. I'll have to fill all this again. So it's okay, which is fine. So this B will become what? 1, and this A will also become 1. Now if I fill this B is not which, this B is matching. Okay, something I've messed up here. 1, and this B is matching with this, correct? And this A is matching with this A. So if I try to match this with this A, this will be 0. If I try to match this M with this B will be 0. If I try to match this with this will be 0. If I try to match this with this will all be 0 because TB, nothing is matching. EB won't be matching. Your MB won't be matching and your AB won't be matching. Now when you're trying to match your A and A are matching. But so see here, this was my 7, this was my 8. Here A and A are matching, but 2 to 7 should also match. So I check index number 2, sorry, index 1 to 7 should also match. So from index 1 to index 7, I check it is 0. So if these are, this is not a substring, I can't say this is a substring. If M to B is not palindrome, I can't say A to A will be palindrome. So automatically this will also become 0. So what I'm trying to, at every point, so if you'll see this point, at M and M, what I'm doing is if they are matching, I'll try to check from 2 to 5. From 2 to 5, these are matching and the length was 4. So 4 plus 2, it will become 6. But here A and A were also matching, but because M to B was not matching, because M to B stored 0. So that's why automatically this will also become 0. Is it clear now?
Yes, thank you.
Okay. Anyone has any other question? Okay. Do you people want me to write the code for this question right now, or will you be able to write it by your own? I'll definitely share the code, proper code with you people on maybe on the meetups, or I'll ask Aditya to share the code with you people, like the final code, running code. But if you want, I can write it right now as well. Or if it is clear, then we can end the session for today. I hope you understood what I'm trying. I mean, even if you don't understand it completely, like you can now go through these questions by your own. Now you will get an idea like how exactly this recursion and how the dynamic programming itself works in these questions. Anyone any questions? Okay. If this is clear, then we can end the session for today. If you have any questions, I'll wait for 2 more minutes. You can ask question, and I'll share the final code. If you want, I can write the code right now as well, the pseudocode.
Abhishek, like I was going through a recursive solution. Like, can we implement it recursively also?
Yeah, you can. Why not? See, this
So,
is all the questions which are, all the questions which can be solved. So the recursive will be a different kind of recursion you have to apply here. What you do is you check whether the recursion will be a bit trickier here. It won't be that
like,
straightforward.
what I was telling, will pass the entire string into the function.
Okay.
So, and if it is a match, then we will go for the substring.
Okay.
The trimmed substring will go, and if it is not a match, then we can either the match will be found from the first to the n-1, or it will be found from second index to the last character. Correct.
Correct.
So, and then again we will recurse both will pass both the string into the same function. Can it work like that, and will track the maximum value?
Okay. Let me think what you're trying to say is correct or not. So you're saying that if this doesn't match. So let's take an example and try to solve. Just a minute. So what you'll do is you'll pass, and what you will keep in your, okay, let's say you have, just a second. What you're trying to
I
say,
have an example here, like let's say geek.
let's take a complex example that it may work on geek. Just trying to see if, okay. Let's say this is given to you. Correct? Now what you're trying to do is you'll start from here. So
Yeah, we'll compare the first and the last character.
Okay, you found a match.
Yeah,
We'll do it.
then we will go for the substring BC.
Okay. You
Then
did
again,
find a match here.
yeah, there we don't find a match. So the substring can be either BCB or CBC.
Okay. Let me think if you are going in the right direction or not. It can be BCB or CBC. Correct. Correct. And how you will store this? Oh, you will store it here itself in the 2D array itself.
Yeah.
And you will end up actually comparing all the numbers as well in that case. So basically what you have to keep in mind is, if let's say there is a mismatch.
Yes.
Correct. Then you will send this string.
Correct.
Or you will send this string.
Yeah. If there is a mismatch, means anyway, if there is a mismatch, the length cannot, the maximum palindromic length cannot be same. It has to decrement by 1.
Correct. Yeah, this approach will work. Yeah, that's a good proposal as well. That will be your recursive solution. And you will end up filling this array itself, this subarray.
Yeah.
And you will keep on maintaining the length. Yes, that will also work. You can try it on your own. Run the code by yourself. This should work.
Okay. Thanks.
Okay. Yeah, this was a good suggestion. Yeah, this will work. The recursive solution is, who mentioned? Suprati. Yeah. Okay, cool. Sounds good. So shall I end the meeting? I'll share the final code with you people on the meetups, or Aditya will share basically the final code with you.
Yeah. Also, can you ask these videos to be sent like as previously we used to get?
I will have to check with him. I'll ask him that if he can share the videos as well.
Okay.
Okay. Thanks a lot. Hope you enjoyed the session.
Yeah.
Thank you very
Thanks.
much.
Thanks. Thank you.